Hello, everyone. Thanks for joining in. We have people joining in from different parts of the world, and we're excited to share you this unique idea of implementing digital twin for transforming vertical transportation using reality capture. So, so for today's agenda, we have uh, different areas of vertical transportation system and understanding the current market scenario and the need that is there for improvement and digital engineering. We'll be going through different challenges that are there within this market of vertical transportation, how digital engineering, BIM, and reality capture in vertical transportation is being implemented, their benefits with live case studies as to how we've been able to support clients in realizing benefits, and then future trends in vertical transportation, and then we'll wind up the session with Q&A from the audience. So we have, of course, myself, Sridhar. I'm associated with Desapex as a design manager, uh, and primarily we take up projects in digital engineering to support end-to-end construction life cycle assets of projects. And we also have Mr. Alessandro, who is the co-founder and CEO of Scanio. uh, I'm excited to share and introduce Mr. Alessandro. He is a seasoned, construction professional. He excels in product and service development, and different areas of uh, construction areas, specializing in vertical transportation. Alessandro holds a bachelor's in electronics, a leadership certificate from IMD Business School, and a bachelor's in management and digital innovation from London School of Economics and Political Science. So before starting Scanio, he was associated with one of the leading elevator manufacturing companies for more than 16 years and has vast experience in this area of expertise. And we are uh, we're honored to host him on this webinar, and we look forward to his insights. So a quick introduction to Desapex. As an organization, we are a team of engineers and architects from different areas of construction. We specialize in digital engineering and implementing various areas of technology for target value design. Our mission is integration of technology for target value design, through which we believe that a sustainable built environment is possible. So we support end-to-end life cycle asset of built assets, right from design to retrofitting, renovation of the overall life cycle of the asset. So as coming to the area of focus for today's webinar, we're talking about the vertical transport system, wherein the construction industry itself is set out to grow uh, by 2025 and reach the overall market value of about $1.4 trillion, and within which there's about 79.06 billions of elevator market share in itself, that is in about 2024. With our buildings becoming more complex and the skyscrapers and buildings becoming taller and taller, the need for elevators is rising, and thereby the overall market value and its importance in the industry is growing more than ever. Um, we will be exploring different areas of concerns, challenges, and different solutions that we've been able to successfully implement in this area. And I will now hand over the session to Alessandro and request him to share his experience and take us through this vertical transportation in digital engineering.
And a warmly welcome to everyone. And thank you, Sridhar, for the introduction. And yeah, again, before starting the presentation, yeah, I'm long season experience, as you already well introduced myself. And we're going to take, yeah, the next 30 minutes So we're gonna go through what is the market, how we see it, the market status today. Then we're gonna move into more specific area related to vertical transportation, and then where kind of the vertical transportation is struggling, especially with the as-built or the kind of the building stock. And then a couple of technical solutions towards digital twin and implementation and BIM. So we have some case study at the end, and then as Sridhar mentioned, Q&A for you. And please, I think you can utilize also the chat if you want to just shoot the questions while we are presenting. Okay, but let's jump straight in it. Please let me know when the screen is visible to you. Be up and coming right now. Is it visible?
Yes, you can see this.
Good, perfect. I said we are also from Scandinavia, very pleased to kind of host this together with Desapex. And then, yeah, starting right away with the opportunity, the building stock or the aging building stock, it's they always require modernization and maintenance, and that is a very big opportunity. So the scene is on the as built and what we have already, what has been already built. So we take now a look in Europe, and then this is already a good kind of Europe is one of the oldest continents, which is the backlog is kind of growing. As you can see, there are a lot of old building, and for example, in EU the building represents the single largest energy consumer, responsible of about 30% of the greenhouse gas emission. And then the modernization of buildings, it plays a crucial role in the climate, in fighting the climate mitigation targets. And the pace of this this upgrade or modernization, or it's very slow. So we are only about 1 to 1.2% of renovation of building renovated each year, which we have more than a half of those buildings in Europe that they are more than 25 years old. And this is actually a good, because we have in this webinar, we are not only kind of focusing on one specific market. It would be interesting also from the audience, how is the market where they are working, or if they have any information they could put. Also, if the market in Europe reflects also their market, or there are changes, they can add it into the chat. It would be good also to understand other continents or other special cases. But then those are the buildings. And anyway, if we take the vertical transportation and we can focus on elevator. Again, if you take Europe, the situation is it's the same. So about 70% of the elevators are over 20 years old, but still, again, only the 1.7% is renovated or modernized each year. Now, again, when postponing renovation, the consequences are increase of maintenance costs, safety risk, then there will, energy efficiency, reliability, compliance issues, negative impact on property value, and the list continues. This is cause a bit bottleneck and underutilized market opportunity. And if we look, what is the challenge here? It's because the amount of old building is kind of, if you think it's growing every year, Then the challenge here is it's really on how we perform certain type of activity in the vertical transportation. For example, how do we assess the condition of the elevators that they are in certain buildings? How do we gather that information? What is the consistency of the information? So all of those are today a challenge in the vertical transportation, and that's what we would like to tackle and discuss today. So how we see it from our side is that the data's or the current way, the current processes are still very manual. Only a few companies they use sorry, some already more kind of online tools. Anyway, everyone that participates into a tender then needs to, send the expert to visit, and see what's in the elevator or in the building. There are differences when different companies, even different person in the same company, you could lead with different results, and then they can be hard to compare or hard to understand certain decisions from, for example, the building owner or when they decide to do certain type of renovation. And then data are scattered and as well inconsistent, and that it's makes very hard to do a property maintenance or prioritization around those data. How about if we think how we can do this utilizing new technologies, and if we can get all this data and all these things in a few clicks, and then in a more easier way. So a few clicks is we push it to kind of underline the need to make the current status more available or quickly available, to make quick or to boost this process. And actually, I like the sentence that's make it and make sure that the right people are doing the right things at the right time, which is a time. I think the time in today's world is a crucial element, and doesn't have to be consumed or wasted in activities that they don't need to be, or they can be improved. And the solution, we think that the solution is in digital twin reality capture, which by digitalizing specific building information, we kind of enables this data to be used wherever you are and whenever are needed, without having a constant flow of people in the building checking only for their company, which makes we like to say also, Scania, that we like to democratize the access of those data. And then when we use digital twin reality capture, we can really create a digital representation, boosting efficiency, and for example, we can use LiDAR 3D reality capture technologies, and a lot of that part of technology is you can get direct online access to accurate building data whenever you are, so you don't actually need to check, for example, how a site is progressing or what are the component situations in certain application. There is no need to visit, even before tendering, for example, if you are in the initial stage of a project. And then, you can recognize spare parts, make a virtual replacement. So much of that, or more, big part of that process can be done utilizing digital twin, and for example, this LiDAR 3D reality capture technology. At the end, what we see coming if we start to utilize digital twin in the vertical transportation is that we gain more efficiency and better productivity Especially, I've listed here 4 points, but there could be many others. I think those are the kind of more are the top ones, at least from my experience, which we can streamline and in the entire modernization process. So from understanding what is there to kind of make sure that the customer receive the equipment, the new equipment, or the upgrades in the shortest time period possible, and can utilize the kind of upgrade or new elevator in the building. For example, imagine that you have a 9-floor building, and then there is the elevator is often broken or not usable, and in that case, the modernization is to happen very, very quick. And we see that with digital twin and that type of technology, we can boost and optimize all the time travels spent to understand what is there in a way to kind of eliminate wasted time within the process or value chain. Then, improve safety because we have less people entering dangerous or hazardous environments. That makes things less, or more safe, less hazardous and more safe. We are far more accurate than the operations or the kind of the way that is being done today. We today already off the shelf, for example, camera like Leica or Matterport or other in the market, you can already reach a level of accuracy which is very very high. We are talking about in very dense point cloud, for example, reaching a plus minus 4 millimeter accuracy at 10 meter distance. So that's a really high accuracy for elevators and as well for other parts of the building. And then, the cost saving, let's not forget, anyway, there are costs involved every time we do a modernization or project like this. And then, the overall savings, operational savings are quite substantial because we minimize the utilization of resources. So again, kind of for me, those 4 main points are kind of the crucial element adopting that type of technology in the vertical transportation. And of course, data and accuracy, makes a difference. You can see now also playing the video. This is one project that we have done where we use a point cloud representation and then meshing it in a way to then have this scan to beam process. The red border, the 360-degree picture. So there are a lot of data that can be utilized out of one on-site scan, and it can really give a lot of more enriched data, a lot of data set. We can enable API connections. So there are a lot of things that can be done compared to today part. This video, it's just a representation, but then I will switch to the next one, which goes to more details in a way, show you what we have done in 2 particular projects. So the first one on the left-hand side, it's a complex building. Is actually a parking lot underground, and that is it's done with the RealityCapture technology, and you can see how that type of process is helping a lot the vertical transportation here, or any elevator manufacturer or going around the elevators, because you can see it's not a normal type of shaft. you have concrete at the bottom, and then there is just steel bars, nothing else up to almost the top, and then again from the top you have concrete, but it's not equal on both sides. So it's to do this with the current methodology, you will need spend days at site to understand the exact position of this, and it's a complex type of building, and using reality capture technology for us this took to kind of build this and scan it. It took roughly 2 hours on site, give or take, to reach this level. And then the second part, I stopped this. The second video on the right hand side shows that it's another project where we actually analyzing how the shaft is actually or has moved, because of building settlement or shrinking, as it's called in more technical terms. And you can see here the orange are the parts where the kind of old shaft is not a plumbed shaft or not straight. And already with this we can show those parts and change as well the visualizations in a way that we can use that type of technology also to understand the exact movement of that shaft in millimeter. For example, in this case, it's between 6 to 20 millimeter, that yellow and orange part. So we can, the technology enables a very deep analysis and understanding of what has happened in the 25 years of life, for example, of this case, to the shaft. Okay, and the next, it's we have done also case study. I said we have done 3 buildings a case study just to put some context and numbers into what we have done, and showing that we are really realizing. So we're not just talking as kind of or displaying nice 3D models, but we actually have done a few projects, and I will start with 3 lifts where we have done it in the normal or current way of doing it, and then we applied a digital twin process or part of the digital twin, so reality capture, and we used Leica, in this case Leica camera, to do it. So we have done, there was a building with 2 elevators, and it was a full replacement. They've done it because the elevator was very old. It was more than 30 years old. And what they've done in this one, they have already removed everything inside the shaft, so it was empty shaft. 9 floors, so 26.56 meter. They were the same. Then to get there, it took 1 hour travel time, and then 45 minutes to survey the kind of all together. Then we kind of did another elevator close by, but this is a little bit different. So because it was already occupied building, 7th floor, 21 meter, and 1 hour travel time again, and then 50 minute little bit survey. And this is what we were able to do, or to retrieve from the survey that we did. So there were the 2D layout, so general arrangements, drawings, 360-degree picture, DB model, downloadable build model, and then as well the best fit shaft. So what I was explaining before, so how, kind of what is the condition of their shaft, of those shafts, and are they, kind of, had they been having, shrinking movements during their life or previous life. How this compares then to today, you can see here the same job or the same project as before done with the SEs. So altogether, summary, there was 3 units. It was a residential and construction site. There were 25 floors in total, so kind of 74.33 meter. In this case, the company that we did with, they already won the order, so there was not in sales stage, but it was already kind of ordered. It was altogether, if we think that you have to go there, do, as today, every company is to go there, so we assume that it's going to take 4 hours travel time, and then more or less 180 minutes, so around 3 hours survey time, and then the output will be just a scattered data as described in the early stage of this webinar. If we do it now, you can see it from the previous slide. Now, doing this with the digital twin process, or kind of with the reality capture as we did it. So now the difference is starting to be on the sales side, so same type of bidding, but then already, this information could be already available earlier, which will decrease a lot of risks in terms of understanding and have deep information either for sales or for engineering, but will be available earlier enough to avoid mistakes or reworks on site. There are 75% of efficiencies here gained because of travel. So basically the company, they can see the data directly on their PC provided to them. And then as well, the survey time is drastically less, so from 180 to 60 minutes, because actually they would just need the time to go and check online and then provide, do their engineering or their quote or whatever they have to do. So definitely a huge amount of efficiency gain, so roughly 75%. And then again, with that time saved, we can estimate that also the sales could be increased, or the right people do the right things. In this case, is very, very spot on. And limited output. So with the reality capture, we are able, as the previous slide, to provide 3D, 2D building information modeling. And then in this case, our accuracy was plus minus 6 millimeter at 10 meter distance, well enough, and very thorough measurements done in this case. As you can see, taking this reality capture or digital twin technology into the vertical transportation, and especially elevators, and that would include also escalators. It's for me or for us, it's kind of the next step that has to be taken in order to be more efficient, more productive, and actually, be more, as I said before, kind of create more efficient in the entire in the entire vertical transportation market. All in all, this is kind of to summarize. For one time that you use, for one survey, sorry, between the normal or the ASIs and kind of digital twin and digital twin process, we kind of see this type of actually savings and benefits. So we have benefits in efficiency and productivity, operational investments due to the fact that do it early. It's avoiding rework on site, mistakes in material sense, and so on, waiting time on site, and then as well each modernization done with new technology or digital twin technology, it's going to remove material waste and travel, so an impact on CO2 emission overall for each survey. So these numbers are valid for each time we need to do a modernization. What we see for the future or the next, how do we see this type of industry kind of adopting the digital twin and reality capture? There are four main. We see four main kind of types or four main elements. So the digital service, definitely a part or an area where digital twin and not only will play a big role. Smart building, and of course, smart building are inside smart cities, which is a direction that many cities, at least in Europe, which is a market that I know more, but not only, they are going towards more predictive movement of people in various situations. For example, if you have a concert or anything, how people moves around, and the digital smart building and smart cities is the enabler of kind of simulating this type of conditions. Sustainable, as you see, the elevators are playing, or buildings in general are playing a big part as well. Elevators, they are one element into a building which consumes and needs maintenance, and it's if we are making step towards be more sustainable in maximizing waste, energy abuse, water, and so on, then it's I think that is the third big part. And then safety, and not safety or safe is not only for the personnel, but I'm including here as well the people, the users, and how the users, the demographic changing in the users as well, is affecting then the modernization of vertical transportation. One example, in Europe, next year there will be a new regulation coming related to accessibility of public buildings, and that accessibility it's changed because it's more related to people that they need special assistance, or they are in wheelchair, or they need kind of different type of access, and vertical transportation it plays a big role here. So all in all, there is this type of way of modernizing and making building and the vertical transportation more smarter, with availability of data, sustainable and more safe. I think those are is what I would like to conclude today, our half an hour together. hoping that we give you a good insight, food for thoughts. And if you want to contact, you can scan to contact me. There are my details, and as well we have Sridhar, uh, as well as the organizer of Desapex, if you want to get in touch with them. So we cooperate together. Um, I don't know if there are any questions because I don't see the chat. You help me. Well, now we can jump into the Q&A.
Yeah. Thanks, Alessandro. We just have a couple of other things that I would like to share.
Go ahead.
All right. I hope my screen is visible. Right?
Yes.
Okay, perfect. So what we essentially saw today and Mr. Alessandro explained is kind of how we can digitally manage our assets, where we have a physical building and we take laser scanning as the base or the technology to bring that physical world into a virtual world using laser scanning and scan to BIM. And then we can further then utilize different systems, different data from IoT, BMS, user generated data. We can all embed that into our BIM that we have developed, the 3D model that we have developed for the project, and then make that as a digital twin. So until here we had the static twin of the building, and then once we embed the live data from your building, maybe it could be the equipment data or the position on off data related to your equipment or the elevator in itself. So we would be able to create that as a digital twin and then use that for further asset management, energy management, building analytics, and the maintenance management itself, including the 52-week planning that we do for our scheduled maintenance. So I just wanted to add on to Alessandro's presentation to highlight the process of how this overall laser scanning process would happen and what are the steps that are going into. And I'm sure some of the audience may have had this question where we use a laser scanner, which is a tripod based or handheld laser scanner which shoots laser beams across in 360 degrees and then hits the obstacles to capture the surface of the overall overall opaque object that it hits, and thereby you will be able to see a point cloud at a very minute grids of more than 2 million points per second, and you will be able to capture the entire surface of the object. So this technology is called RealityCapture, where we will be using this tripod mounted scanner as you see this operator holding this. So what the process of capturing existing conditions goes like this: planning the site, scanning the building, processing it, and then publishing the data in 3D and getting the deliverables, where basically the planning phase is the initial set out that we do in trying to understand what are the areas that we want to capture and how, uh, according to the physical conditions on site, what are the changes that we would need to do and how many points, how many locations would we need to scan. And then we further go into scanning, then take that scan data into processing, and then extracting BIM models or 2D drawings from that output. So it looks something like this. We initially the initial rough sketching is done, where based on the existing location, the building, which all floors are we capturing, what are the areas that we're capturing, how many shafts, how can we access the shafts, those are all planned. A rough sketch is identified, and then we go ahead into scanning the facility, where you will notice that uh, there are captures of inside the shaft, so we would need to move the shaft in different locations so that we will be able to access the void within the shaft, and then ensure that the overall shaft right from the lowest level to the highest level or the machine room or the bottom of pit are all captured to ensure that continuous scanning for the entire elevator bed. And then that capture data, which are individual images, basically are taken into the software of the OEM of the laser scanner to process and stitch that data together to make a seamless continuous building that we can notice. And then it would be us taking that scan data as kind of xref. For those who are familiar with AutoCAD, you would be basically xrefing the entire point cloud into your uh, 3D modeling software, where you will be able to trace and also utilize some of the automated tools to create the surface of the shaft walls and also the shaft doors, shaft openings, and the position of the equipment. So, and then automated dimensioning or adjusting the dimensioning as to how you want to see it. You will be able to create an accurate as-built drawings for the documentation of the overall existing conditions, which you can further utilize in planning the position of the equipment or utilizing for maintenance and retrofitting activities. So this is basically the overall process of how laser scanning is conducted, and you can get outputs as 3D models or extracted 2D drawings. So now uh, that's it that I wanted to add related to the laser scanning process and how we can extract data out of it. So if there are any questions, we can go ahead to take it. So there is one standard question that I see here related to the accuracy of laser scanning. Uh, the laser scanning is primarily dependent on the accuracy. We can expect accuracies in millimeters. The claimed accuracies from the OEM is in the range of about uh, you know 3 to 4 for every 10 meters that it captures. So the range of a laser scanner is up to 130 meters for some laser scanners, and it ranges as an average for up to 100 meters from the point of scanning to the object that it hits. Right. Right. Alessandro, we have one question. You can see. Would you like to take it?
Uh, where are the questions? I don't see the questions.
So you see the Q&A. That's a blue color
Yeah.
question mark.
Okay. Now, yes. Now the yeah. Good. Is there potential for combining digital twin technology in vertical transportation with other building management systems like uh, AVAC or fire safety? Yes. The same applies to anything that goes vertical, for example, like pipes, and you can use the same type of application. But as Sridhar said, in the process basically allows you to perform the scan in any other parts of the building. Is not restricted for vertical transportation or other. So definitely, yes, it can be used for those as well.
And to also add on to that, so you can always bring in the live data from BMS and other sensors of HVAC equipment into the digital twin platform, where you can connect
Yes.
the data that is live and include that along with the, I mean, if you see the overall building as a system, you have multiple sub-disciplines or multiple subsystems, where vertical transportation is one system. You have HVAC system, electrical, fire protection, plumbing, and many other systems that are within that building, that can all be brought in terms of its data, both physical geometry and also non-geometric data, which is both static as well as dynamic. Static data as in its functional information, technical information, and then the live dynamic data that we have of sensors and IoT data that you get from the equipment running status, or the power consumption data. All of those can be brought into that digital twin. So yes, it can be done. Thank you for the question. Then so we are at the end of this session. If there are no questions at this point, we can close the session, and feel free to reach out to us. Uh, Feel free to reach out to us if there are any other questions that you would like to discuss, or have any ideas that you would like to share. Mr. Alessandro's details are attached with this. You can always reach out to us, or to Desapex or Mr. Alessandro, and we can support you in addressing any of the queries that you may have. So thank you for joining this session. It was a great session, Mr. Alessandro. Thank you for joining with us and sharing your valuable experience. And I'm sure this area of topic that we discussed about is going to grow in a huge exponential manner, because with the amount of buildings that are being built, and the asset management and maintenance activities becoming complex and complex by the day, there is a continuous need of bringing in this accurate documentation and also digital twin for vertical transportation system, and uh, will be there to support. Thank you.
Thank you also to you, Shridan, for organizing this, and thank you all for participating. All right, we can close it, I think.
Yes. Have a good day, everybody. Thank you.
Have a good day. Bye.